Okay, so this is going to be a very quick video on how to do chi-square test for independence on the TI84, which is going to be the same, I think, as an 83, that general kind of area. Um, so I asked these two questions. Are you male or female? Do you prefer as pets or friends, cats, dogs, birds, or reptiles? Um, and I put reptiles, amphibians, and fish all together. I got very few birds, so we're probably going to end up with a chi-square test that's a little bit questionable. One thing we could do is put the reptiles, amphibians, fish, and birds all together. Um, but anyway, we'll just run it as it is right now and recognize that our uh, low value will probably be um, make the test questionable, and then maybe we'll run it the other way too. So because I have this in a spreadsheet form, because I ran a Google form to do it, I'm going to delete that top row, and then I'm going to want them in the end by cats, dogs, male, female, right? So I'm going to go to this column first, and I'm going to say I want it ascending, and then I'm going to say to expand it. That means keep these partners together, so that female will still have dogs next to her, that male will still have dogs, like that. And then, now that this is all in order, now I'm going to order this one as well, and it will maintain the order of the other side because it just keeps them in the order that they are, except for grouping. So like that one will be at the top of the dogs, that one will be the second one on the dogs, and so forth like that. But I still want to expand the selection because I still want to keep them together. Okay, so now I can see I have 3 females that said birds, and I have 2 males that said birds. Female cats, it's all the way 43 minus 5, so 38. Males, 57 minus 43. $115 minus 57 is 58. $152 minus 115. And you could always do it like this too if you want. And let it do that calculation for you. And then here, female, we have 161 minus 152, and then 4. Okay, so once I see that 4, and up here, the 3 and the 2, those are pretty low because we're always wanting the expected values to be above 5. So like in this case, because these are 3 and 2, there's no way the expected value for either gender could be above 5 because there are 5 total, right? But at any rate, let's run it like this first. And so what we're going to do, I'm just going to put over here so that I can kind of keep in mind what I'm doing. I have male, female, and then I have 4 options. I just put some borders on that so that I remember. So cats, dogs, birds, like that. And so for the birds, it was 2, 3. I probably should have put female, male so that this would be in alphabetical order, and I could have made this in alphabetical order, and it would have, been easier for me. But anyway, the cats are 38 female, 14 male. The dogs are 58 female, 37 male, And these are 9 female, 4 male. Okay, so remember what we're checking is if it's independent of gender, if pet preference is independent of gender. So we don't really care if there are a whole lot more females or a whole lot more dog lovers. We just want to know, is it related? Are these two things affecting each other? Okay, so here's what we do in a TI84. The first thing we do is create a matrix. And so we go to matrix right here, so second x inverse. And at first we want to edit one, so we'll just choose A. So we want a 2 by 4. Always rows first, columns second. So 2 rows, 4 columns. And then I'm just going to enter them. 14, 37, 2, 4, 38, 58, 3, 9, like that, okay? Then I'm going to quit. So it's a kind of weird setup because we're going to reference that we want to use B as the expected value matrix. So in the Inspire, you don't do that. It just does it. But in this one, you have to tell it that, but we still don't have to calculate the expected values like we did by hand. It's still going to do it for us. So when we say, oh, well, A is our observed value, B represents our expected value, it then populates B for you. So you go to Stat, and you go to Test, and you go down to chi-square. Okay, so we have chi-square test, chi-square goodness of fit test. We're wanting the test of independence. That's the one that doesn't state what it is. So you choose C, and then you say the observed is A, the expected is blue, the expected is B, but we do not put anything in for B. And here it is, degrees of freedom 3, because it's 2 minus 1, which is 1, times 4 minus 1, which is 3. So 1 times 3. The probability is 0.51. That's huge. That's chi-squared is very small. The probability of this difference is over 50%. And you may be looking at it and thinking, gee, that 9 and 4 is way different. But as it happens, we had 108 females and 57 males. So we had approximately half as many males. So approximately half as many liked amphibians, reptiles, So it's all in line. Now if we want to go back and change it, where we put these two together, then here we would have 6, and here we would have 12, and here we would have nothing. And the reason that we would want to do this, oh, I can't click the right thing here, is because if we go in here to matrix again, and we just have a look at B, we'll have values in here under 5. See those? So when you have values under 5, it sort of invalidates your test. It normally invalidates it by making it more likely to reject the independence because you have these tiny denominators, so you're adding giant numbers. So in this case, it should not change our outcome. But if we wanted to do it that way, then we just go back to matrix and go back to edit. And this time we'll make it 2 by 3. And we'll go change this 2 to a 6 and that 3 to a 12. And then, well, instead of editing, I'm just going to choose C as our output matrix now. So I'm going to go to tests, and let's see, maybe it was B? No. I'm going to look at it this time. Test. So chi-square is C. So we can go alpha C instead of doing the scroll down business. So this time I'm going to do C. And the degrees of freedom went down because now we just have 1 times 2. And the probability went down some, but it's still a lot. It's still huge. So it's definitely, this P is definitely greater than 0.05. And this chi-squared is still very small. The chi-squared before was like 2.37, but the reason that the probability dropped so much with that little bit difference, and this even went down a little, is because the degrees of freedom is also less. Okay, so anyway, this is how you run a chi-square test of independence on a TI84.